Number 16. Number 16 is our parent function is cubed root. We have that negative 4 on the outside, so the negative is a reflection over the x-axis again. The 4 on the outside is a vertical stretch by 4. And minus 2 on the inside tells us to pick it up and move it right 2 units. So in each graph here, we're going to plot every point that fits on the grid that we're given. So cube root of x, 0, 0, 1, 1, 8, 2. And then remember, for cubed root, the negatives exist. You're not going to get an I when you do the cubed root of something. So negative 1, negative 8, negative 2. Oh, that was going to be ugly. Try to do a nice job, graph. One more try. Alright, that's pretty good for me. To reflect this over the x-axis, we're going to take everything below and move it above. So kind of the left branch is going to move up above the x-axis, and the right branch is going to move below. Again, we're plotting specific points. Vertical stretch by 4 means that every y value is going to get multiplied by 4. That does not affect your y at 0. 0, 0 is not going to change. It does affect negative 1, 1. Negative 1, 1 is going to turn into negative 1, 4, multiplying 1 by 4. Negative 8, 2 was our other point. When we multiply 2 by 4, we get 8. So negative 8, 8. Again, I'm just taking those original or y values from the step before and multiplying them by 2. And those y values were 1 and 2, and negative 1 and negative 2. So we're just multiplying those y values by 4. So negative 1 times 4 is negative 4. That's our y value at positive 1. Negative 2 times 4 is negative 8. So at 8, we're going to go down to negative 8. It's a much wider cube. And now we're going to take that whole situation, pick it up, and move it right 2 units. So I'm going to move the point that was at the origin right 2, and then move everything around it. So over 1, up 4, over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 8. So that point's going to be at negative 6, positive 8 now. So that's kind of the left side of our graph, the right side of our graph, over right 1, down 4. Sorry, there's a lot in between there. And from our little center point there, right 8, down 8. So down to over to 10. Again, none of this is approximate. Everything we're doing, we're plotting points exactly. Your graph doesn't have to be beautiful. I'm not terribly happy with the symmetry in that graph, but all of my points are plotted correctly. All right, let's go ahead and do number 17 on this video as well. So this one didn't print very well. This is like the little double bar guy. This is greatest integer. Greatest integer function is a little bit of a thing to graph on our normal graph. Greatest integer function, 2 transformations for this one only. The 3 on the outside gives us a vertical stretch by a factor of 3. And the 1/2 on the inside is a horizontal stretch by 2. Remember, if you're saying to yourself you're doing a horizontal shrink or stretch, you have to make sure that you are flipping that. So that, you know, when we take it out of the function, we're really practically using a 2 there, not a 1/2. So the way the greatest integer function works, this is probably the most questions about, the one I get the most questions about, is it's also called a step function. The greatest integer function has a closed circle at 0, 0, a little bar, and then an open circle at 1. And it jumps up, closed circle at 1, 1, bar, open circle at 2, 1, 2, 2. The other way you can think about this function is it's kind of a round down function. Put in 4, get out 4. Put in 4.1, you get out 4. Put in 4.9, you get out 4. You know, function, you can think about functions as little machines. Back in your Algebra 1 life. That's maybe how you talked about functions. If I was going to give you a greatest integer function on a test, I probably wouldn't give you a 10 by 10 graph. I'd probably give you something a little nicer, maybe a 5 by 5. This one isn't so bad once we get the parent function drawn, though, because we're going to be stretching it in both directions. So here your open circles are on the right, your closed circles are on the left. You have your little bar between. It looks like stair steps. You are not, this is a function, so you're not using any x value twice. Okay, our vertical stretch by 3. Our vertical stretch is not going to affect our first little step. So 0, 0, closed circle. 1, 0, open circle. Then instead of stepping up 1, we're going to step up 3. So our next closed circle is over at 1, 3, little bar, open circle. Up 3 more. That points at 2, 6. Up 3 more. 3, 9, little bar, and open circle. And the same thing below. We're going to have an open circle 3 units below our closed circle at 0, 0. Open circle at 1, negative 6. Closed circle at negative, I'm sorry, yeah, 1, negative 1, negative 6. Closed circle at negative 2, negative 6. Open circle at negative 2, negative 9. Closed circle at negative 3, negative 9. So now when you're doing a vertical stretch by 3 with a step function, you're just putting more space in between your steps. The horizontal stretch makes your steps longer. So now, instead of having our steps length 1, our steps are going to be length 2. But again, this is a function, so we're not going to have any that overlap each other. So I'm going to keep my step at 0, 0. Now it's going to widen out and go out to 2, 0. I'm still going to go up 3 from that vertical stretch, but I'm not going to overlap. So I'm just going to fill in that closed circle. Again, my step length is 2 now. And my step height, kind of between my steps, is 3. So we're not increasing our number of steps that fit on our graph, just the length of our steps. Over 6, up 9. And my step is too wide. So that open circle is at 8. Great, same way, we're doing this backwards now. Open circle at 0, negative 3. Closed circle at negative 2, negative 3. Open circle right below it. Closed circle at negative 4, negative 6. Open circle right below it, down at negative 9. Closed circle at negative 6, negative 9. And we don't need this last graph.